We're going to talk briefly about Tetris for intro intermediate programmers. This is for the Mount Lebanon High School AP Computer Science course in Tuesday, December 15th. To begin with, here is a actual copy of the Tetris we're going to make. I'll hit R to reset. I'm hitting left and right arrows. Notice it doesn't go off the board. Down does make it go down faster. There's no drop. I'm hitting space, nothing happens. So you can go left and right. And notice here when I get to the bottom, I'll quickly go left, and you can keep moving when you're at the bottom very briefly. Down, down, down. As for rotation, up arrow rotates, and it rotates only in the counterclockwise direction. So I will go here, up, 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 up. You see that? Let's go here, and I'm trying to get a full row to show you full rows emptying. There we go. I'm going to get 2 full rows empty, and then my score goes up by 4 because your score goes up by the square of the number of rows that you clear out. And so this is Tetris. It's maybe not the very best version of Tetris ever. For instance, we're not doing previewing of next pieces, and the user interface is a Tetris user interface, but not the most advanced one. But nonetheless, there's no question that this is Tetris. So let's actually do this. We'll leave with that. See, I'm leaving that one blank. And the reason I'm doing that is to demonstrate what happens. To make sure you see you can fill a row. I'm going to fill the 3rd row up, and it just emptied, and the bottom 2 rows stayed, and the rows above the 3rd row dropped. Cool. Tetris. Wonderful. All right. So to begin with, you have to follow this design and only this design. There are many different ways to write Tetris. This particular assignment is about you following this particular spec. Okay, we are going to use JComponent with events. In our design overview, we just showed this. We're going to have the board itself. It's going to be a 2D list of colors, as we'll see in a minute what that looks like. A 2D array, I should say, of colors. Okay. This falling piece right here, the piece that's dropping, is actually not on the board. It's layered over the board, much in the same way that our food in Snake was not stored in the board. We could have stored the food as say like a -1 on the board, but we did not. We stored it as a food row and food col, so that was completely separate from the board. In the same way, this falling piece is not stored in the 2D array of colors that are in the board. Instead, it's stored separately with a falling piece row and falling piece col, and then we draw the falling piece over the board as it falls. Okay, so this is what a piece looks like. A piece is a 2-dimensional array of booleans where the true values say where inside this rectangle are the actual pieces or parts that are part of the piece. You can see how this looks like an S. You have an S piece, you have a Z piece, and so forth. Okay. To continue, we'll start by painting this particular picture. We put these rectangles in the corners in order to make sure that we're drawing correctly and drawing the rectangles in the corners. So we put a red, white, green, and gray rectangle in these corners. Make sure that you use this code, just like we have here, and make sure that before you go past the stage, something comes out that looks like this. Then delete out the rectangles in the corners, because naturally you can't really play Tetris with rectangles in these top corners that way. So, although to tell you the truth, in most cases it wouldn't be too disruptive, but still get rid of them. Okay. What else? That's fine. Onward. So for the piece types, as we said, this is what a piece type looks like. Okay. And here are all the pieces, I, J, L, O, S, T, and Z. Okay. These are the official names of these pieces, in fact. Okay. So now we need to store a list of all the different piece types. Okay. By the way, pieces are also known as tetrominoes, if you're wondering. Okay. So we're going to have a list of Tetris pieces, which is a list of each of these pieces. Now here's the thing. A Z piece is a 2D Boolean array. A T piece is a 2D Boolean array. This Tetris pieces is an array of 2D Boolean arrays, making it a 3D 1, 2, 3D Boolean array. Cool, 3D arrays. It's really an array of 2D arrays. So it's really, because Java really only has, in some sense, 1D arrays, right? You have arrays of other arrays. So what we need is a way to store colors that correspond to each of these pieces. So we want to have a piece colors array saying that, hey, all the I pieces are red, all the J pieces are yellow. This one only has to be a 1D array of colors because what we say is, for instance, Tetris piece colors of 2, that's magenta, corresponds to Tetris pieces of 2, that is the L piece. Right? Now we have to create a new falling piece. When you create a new falling piece, what do? Well, first, you randomly pick one of these pieces. That is, you pick an index that's a legal index inside your Tetris pieces. Okay, say we pick that one, T piece as it turns out. Then you also set your piece color to be the corresponding color. So you use the same index into Tetris piece colors as you use into Tetris pieces. Now we have a random piece. You have to place it on the board. But where on the board? Let's go get a board for us. Here. You want to place it in the top row. Okay, so your falling piece row is going to be 0. As for your falling piece call, you'd think you'd put it right in the middle, which is calls over 2. It's not going to work because the falling piece call represents the left edge of the piece. Now, if our left edge was here, imagine we had that the piece, the I piece, laying on its side, going across. It won't be centered. What we want is for the center of the new falling piece to be in the center of the board. Therefore, what you have to do is subtract off half the width of this new piece, half the number of columns, so that it's centered, so that as it enters the board, it enters at the top row, but centered. Okay. All right. That's fine. And then you paint the falling piece, sure enough. I'll let you read about that. And then we add this test code here. This test code says every time we press a key, have a new falling piece. This is nice test code so that all you do when you run this is keep hitting keys and make sure you keep getting randomly chosen pieces that are at the top of the board, centered, and that they're in the correct colors corresponding to the piece types. You can just keep hitting spaces to verify that. Okay. So now we need to move left, right, and down. Okay. So left and right are easy, right? All you have to do is, if you hit the left key, subtract 1 from the falling piece call, and if you hit the right key, add 1, and if you hit the down key, just add 1 to the falling piece row. So all of that's actually easy. What makes it harder is making sure that you're on the board, because eventually you'll go left, you'll go off the board. So there's 2 different ways we could do this. One way would be before we make the move, to do whatever math is necessary to make sure the move would be legal, and then make the move. We are not going to do this that way. Another way instead is to make sure the move is, to just do the move, and then make sure the move is legal after we've made the move. So just say, are we now in a legal state? And then if we're not, to undo the move we just made. This second approach is preferable because that allows us to have a single test to see if a move was valid, regardless if it's a left move, a right move, or a rotation. Wonderful. So we have move falling piece, which again tries to move it, checks if it's legal, and if it's not legal, undoes the move. To undo a move means to reset the falling piece row or the falling piece column. Okay? A falling piece is legal if every single part of it is on the board and it's not covering, the parts of it are not covering other things on the board. In other words, every part of it is over blue in our example, right? Over empty board. So here's our empty board, right? There's our empty board. And let's see if we have a falling piece. Here's a falling piece. If every part, that means in this example, these 4 red rectangles or squares, if they're all on the board, which they are, and they're all over just blue squares, empty squares, then that's legal. If either of those are not true, then it's not legal. Okay. All right. And then key press, you of course have to update your key press to allow it to move. All right, so now the next thing you have to do is we need to be able to rotate, which is one of the harder parts. Okay, you want to look at this picture to show you that when you rotate a rectangle counterclockwise, a couple things happen. First, the dimensions of the rectangle change. Notice it's wider than tall, but after we rotate, it's taller than wide. The dimensions change. That's really important. Second, you have to keep the corners straight, which is why these colors are helpful. Notice the left top corner after rotation becomes the left bottom corner. The right top corner after rotation becomes the left top corner. So what we see is that top going from left to right before rotation is the same as going from bottom to top after. Going from top to bottom before rotation is the same as going from left to right after. This is good to bear in mind and check that these things are true with your own rotation code. I should note that rotating is probably one of the two hardest parts of this. The other is removing empty rows, or pardon me, full rows. In any case, the hard part of rotation is, as underlined here, keeping the center of the falling piece constant. In other words, when you rotate, you should, for each piece type, find what you think is the center of it in the row and column. Now, if there's an odd number of rows, it's really easy to find the center. But if there's an even number, it won't work out to be like the exact center. That's okay. You fix, you get as close as you can, and you fix a row and a column as the center, and then you rotate about that cell, which is to say, let me rephrase that that cell does not move. Okay, it maps to itself. And here's one more way to test that you got this right. When you test this, you should bring a piece into a legal position so that you can rotate it, and then rotate it and keep rotating it without it falling, right? So that you don't, because we don't have pieces falling yet. And what should happen is it should just rotate back and forth, and it should not walk across the screen. If you change the center on rotation, you will see this clearly as one of two effects. It'll either just literally just walk across the screen and eventually to the side of the screen or off the screen, or it'll just kind of bounce back and forth. You'll watch the center jumping. Either of those are wrong. The center should not move. Okay? And here's a little hint that you should read about one way to see if you can implement that. All right? So now you update key press to have up arrow will give a rotate left. Okay? And again, here's your hint. If you rotate over and over again, the piece should stay still. All right. So now dropping the piece. All right. So now all you have to do for this is add to a timer event, just move the falling piece one row down. So on each timer event, click, 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 we move one row down, one more row down, and so forth. It works pretty well. So we're saying it might fall too fast, so you have to adjust the time interval. Okay, I'll let you read about that. But the second thing is when it gets to the bottom, it'll just sit there because it'll try to move the piece. It'll figure out that it's off the board, so falling piece is legal. It'll say false, and then it'll do nothing. Well, what do we want to really do at that point? When the timer fires and a piece falls, if it can't fall, that's when you want to place it. And let's be clear what we mean by place it. Okay. Here, this piece is not on the board. It's drawn over the board. But when it gets to the bottom and it can't fall any further, then we copy cell by cell the pieces, the colors, into the board. So we place the piece on the board. Okay. By the way, doing that, the code for that's going to look very similar to the code for drawing the piece. You're going to go cell by cell through the piece, and you're going to place it on the board. Once you have placed a piece on the board, now it's no longer a piece. It's just individual colors on the board. That's very important because you can clear a row, for example, which takes parts of one piece but leaves other parts behind. That's not a problem because, again, once they're on the board, they're not pieces at all. They're just colors. Okay? All right, so, and then once you place the falling piece, you have to then call a new falling piece to create a new one at the top that's centered. And then how do you lose the game? You lose the game, or the game ends, I should say, when at that precise moment when you try to place a falling piece, it's instantly illegal. It's immediately illegal. And that would be because the board is full all the way to the top. And then you try to place a piece, a new piece. That new piece is illegal immediately. Game over. Okay? You could read about what to do when the game is over. All right, so now we have to remove full rows. Removing full rows is a little tricky, and it's described here. And in particular, what you have to do is be sure you don't copy, because you have to copy down one row into another. Don't use this as a way to copy rows. We've learned about the fact that if you do this, you won't get a copy of the array for the old row into the new row. You'll get an alias. And when you have aliases for your rows, really bad things happen because whatever happens in one row will happen in the other row. So avoid code like this. If you have code like this, you'll have really bad bugs. I'll leave it for you to read the rest of this because it's an interesting and challenging feature. I will say that removing full rows is probably the second hardest part of this. Finally, there's more ideas that you can do and a bunch of these, but frankly, with this due on Friday, don't feel the need to do these. These are all bonus and not necessary to get full points on this. That's just a brief overview of Tetris. Don't stress too much, have fun, and do support each other. Remember, we are a community of learners. All right, have fun.